Around too much.
So 5.7 would be okay?
What? Yes, 5.7%. Yes. I couldn't remember what it was.
5.7.
And Joseph Brown's husband, right? And what's your class? I'm 7.
All right, guys.
So it's 5.7. No, I left after sophomore year.
So weird. I have things up here too.
5.7.
Nita. No, I did it.
Yeah.
Wow, this is freakadelic. I got the exact wrong lights turned on. Can you play with those lights in the back? I give you permission. Yeah, let's try to get the ones in the back turned on. There we go. Now, let me see. I know. I just did the wrong one. Shit. Do it again. Or don't touch anything, but pretend like you want to. Okay.
Okay,
All right,
leave it.
screw
Don't touch it.
All right. This is good enough. Thankfully, got a pretty powerful projector in here. You can see that. All right, the first one's very straightforward, hopefully. Right, what do your stems look like? My stems.
2, 3, 4, 5.
1. Is this a 16 there? 2, 3, 4, 5. And no 60s, right? So what's in the teens?
6.
Yeah, just 16. I like it. 20s. 2 and 3 and 5. 2, 3, 5. 30s. Yeah, 1, 2, 2. 3, 5, 7. 8. I like it. Yeah, 1, 1, 6. And that's it, right? There's a 40. No, there's no 40, is there?
No. No, there's not.
No. Oh, and then 50 is 0, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 in there. Okay, good. What really, really sucks, and this is just, there's no way around it, is you're going to be using the calculator, putting stuff into lists, and you're going to get them all in there. There's going to be 28 you put in there, and there's supposed to be 29. You're like, what did I miss? Shit, you got to go back. It's just part of how this works. A lot of those jobs that are like work from home, make lots of money, it's data entry, because nobody wants to do data entry. 28, 47, you know. But data has to be input so it can be processed and analyzed and spit out and whatever. What am I missing?
Key.
Key, good. Key. Doesn't matter what you pick. I just pick the first one almost always. 1, 6 means 16. I like it. Now, a few people got this one. My hint was you normally break it down, like in this case it'd be 4.0 to 4.9, so like by tenths. Maybe it'd be better to go 4, 4, 5, 5, where it's understood this is 4.0 to 4.4 and this is 4.5 to 4.9. You get better resolution then. When do you do this? When you would only have like 1 or 2 classes if you didn't. That's not enough resolution. Does that make sense? If I made a histogram and I had one big-ass class, does that tell me anything? No. 2 classes barely tells me anything. I need more resolution. I need more classes so I can see how they were distributed amongst everything. So 2 rows, 4, 5, doesn't tell me much. I need to break it down a little more so I can really see where things are clustering, where things are gathering. So when you do this, what do you have? 4, 0, 2,
There's 2 zeros.
2 zeros, and then a 2. Looks like it. I like it. Because 4, 5 is going to go down here. So 4, 5, 4, 5.
Why won't you put a decimal? Like
Because what am I going to do for my key? 4.0 means 4, no. We know better than that. 4.0, right? Because we know what the data looks like. So you don't have to put decimals in here. You don't put commas in here. You don't put decimals in here. Any of that shit is in the key.
Okay.
That tells somebody how to read each piece of this so I don't have to write as much. I like it. So 5, 5, up to 5, 4, 9, right? And then 5, you would do 5, 0, 5, 1, blah, 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 blah. And then you would do 5, Is there any 5 5s? 5 5, yep. 5 5 5 5. That's another way to set up a stem and leaf. Instead of breaking it down by tens, you can break it down by 5. So instead of breaking it down by tens, I can break it down by 0.0 to 0.4 and 0.5. I can break it down a little further. Okay, not terribly exciting, but now you all know the answer. Some of you guys came up with it. Good. Okay. Now this one, I like to do one where it's already created because it helps you figure out when you're making one, you know it a little better. Now I didn't mean this to be tricky, but is everybody? Most of you guys caught on to this. How tall is this really?
11.
11. It's like halfway, right? I can just cut off the top of the picture. So there are 11 people in this class alone, and then there's 6 in the next door. That's 17, 19, 20. So there's 20 people that were surveyed, right? These 11 people, what is it that we know about them? Those 11 people, what do we know about them from this? Shabba. What? Say it again.
Shampoo lasts.
Good. I like it. Shampoo lasts 0 to 20. This person, like, the whole bottle, the cap just fell off. Oh, shit. I don't know. So 0 to 20 weeks, that's how long it lasted for those 11 people. And then these 6 people, it lasted 20 weeks to 40 weeks. I like it.
So it's a distance.
Me, if I get conditioner ever, it lasts me for like a few years. I'm like, when did I buy this thing? Just thought you should know. How many classes are there? Now, there are some empty ones, so you don't just not count them. You wouldn't say, how many classrooms? Well, that one's empty. Let's not count that one. What the shit? 1, 2, 3, 4, 5, 6. So there are 6 classes. The class width is a single number, but it defines how wide every class is. So it doesn't matter what class you look at. I'm going to look at the first one. How wide is that? 20. So tell me real quick, do you guys know which way did they do this? This way or this way? The left way or the right way?
Your way.
My way, I like it. And that's why they got nice whole numbers and stuff like that, 0 to 20. So real quick, is 40 included on this side or that side? Oh, shit. It would be included on the upper side. That's why for that at least 41, you don't count anyone from in here. Because these people are all less than 40. That one is 40 and up. Yes. So for what percentage of the sample? Well, out of 20 people, how many had it last at least 40 weeks? 2 plus 1, 3. And 3 out of 20 times 5 times 5 is 15%. You guys remember that? Make it out of 100. You see the percentage? Say again?
How do you get 3?
How many people had it last longer than 40? These 2 people and this one person. So 3 people. Out of how many people? Out of 20 total people. I like it. I like it a lot.
Okay.
Oh, sure.
What about that 0.5 that was there? Oh, no, that's multiply. One second.
Yes, that's the best way to make something over 20 into a percentage. Make it out of 100, you got a percentage. Yes? In fact, the percent symbol is the number 100 rearranged. Here's, that's what percentages are. They're out of 100. Okay. Now this guy, I do apologize that you had to put it in order. That's too damn bad. Eventually we're gonna learn how to make the calculator sort it for us like this. Yeah, you get one of these new ones, they're all slim and they're all backlit and shit. Anyway, sorry. So hopefully you guys got it sorted correctly. To find the class width, it's going to be how wide every class is, like that 20 was on the other side. What's the highest data point? 79. 61. And I tell you now, I'm not going to normally tell you how many classes to use. But you would definitely not use 10 classes for this little tiny sample. Here I say you use 5. So you get 18 over 5 is 3.6, which you round up to 4. Which means, technically you could start at 60, but and that's fine. You totally could. You got to start at the first data point or right below it. It's up to you. But let's just start at 61. So this next class is to start where? 65. So this one's got to end at. Now, real quick. I know this is yes.
Let's start at 64.
Why? How wide are the classes?
Oh, never mind, guys. It might be the other way. 60.
Oh, okay, I got you. Yeah, I started at 61. Real quick, if you still don't like this, like because it looks like it's 3, and you said it was 4, remember where does this really start? 60.5 to 64.5, and what's 64.5 minus 60.5? 4. So the freaking width is just hidden when you do it like this. Nothing's hidden when you do it like this. And again, so you can choose. Okay. So this would be, I can just keep adding 4. Woohoo! Woohoo! And then just keep adding 4. Woohoo! There you go. No, Jeff. There you go, Jeff. You did it. Yay. So the last number does not have to be the highest number. I always see people trying to force that to happen, and then, oh, there's a... So now you say, how frequently does the number show up in between those? Well, 61 to 64. Yeah, 1, 2. 65 to 68. I'm going to take your word for it. There's a lot of them. Shit. 11. 69 to 72. Holy shit. Yeah, that looks about right. 73 to 76. 7. And then 77 to 82. And you hope to God these add up to be 35 because it's 35 total people. Don't write 33 down there and not do anything about that. That's a check. You're checking. So 13, 26, and 35, yay, check. So how do I do relative? We haven't talked about this yet, so don't freak out too much. But relative frequency, this would be 2 out of,
35.
61 plus 4 is 65.
Oh, you go down, not to the right?
Totally. Because again, what is this really? 60.5 to 64.5. There you can see this. You can see the 4 now. So it's hidden. It's the boundaries, not the limits, that you can see them. 2 out of 35 comes out to be. So is it? Oh yes, 5.7 sounds about right. Yep. So 5.7% roughly. And generally just round these to one place. We're going to do this by hand, so I don't think we can make the distinction between 5.7 and 5.71%. So one decimal place is good. It won't. The rounding won't be so bad to throw off your final answer here. 11 out of 35. What is it? 31.4. 13 out of 35. 37.1. You just add these two, right? 2 and 11. 7 out of 35. That's a nice one. 20%. And 2 out of 35 again is 5.7%. Now, if you add up all these percentages, how do they come out? 99.9? Close enough for government work. Cumulative frequency. Cumulative just means you accumulate as you go down. So far, how much have I seen? 5.7. Now I've seen 31.4 more at this point, so that's going to be 37.1%. Now I've seen another 37.1%. That's 74.2%. And then add 20, 94.2%. And then add 5.7, 99.9%. All right. So cumulative frequency just accumulates. You just keep accumulating. The last entry should be close to 100%. So you'll see that in the book. I don't make a big deal out of cumulative frequency, but you'll see that in the book. I like it. Oh shit, it's almost done again. And then finally, the last step, 60.5, right? 64.5, now I can just keep adding 4. Sorry. Father's heights. And I ask you to make a relative frequency, so be careful. You got to pay attention. I might say frequency, or I might say relative frequency. So I need to be able to go up to 37%. So maybe I can do 5, 10, 15, 28, 25, 38, 35, 40. Yeah. And then, so that's that scale. This is going to be real freak. And then the first bar is going to go up to about 6 almost. Just over 5. And then up to 31. Just over 30 there. And then up to 37. And then up to 20. And then up to 6 again, roughly, almost. Now, real quick, does that look like a bell curve? Like a little bit. This is a little bit taller than you would expect, but it's roughly bell-shaped, or more specifically, normal. We call this a normal curve. So when teachers say they curve the grades, they just pick the curve up and they move it. That's what curving is. So the highest grade was an 80. We now take that to make that 100, and then we see where everybody else fell. That's what curving grades means. Interesting. Okay, I think that's about time right there, if I remember correctly. So we made it up through 2-2 today. All right. Oh, what do I want to say? Next Wednesday, we'll have a quiz. Chapter 1 and Section 2-1.
Do we keep this paper?
Yeah, that's yours.